Welcome into the discussion about connected and static routes. Now, I could have drawn up a big, long, boring slideshow about connected and static routes, but this is one of these subjects that is easier just to show you how it works. And so, as a result, I have built a very small network in GNS3. Now, if you happen to be playing along at home, I have included the configurations for all three of my routers, Jake, Jane, and Roxy, in the work files for this particular section. But essentially, each of the three routers have three networks defined on loopbacks, 10.1.1.0, 10.1.2.0, and 10.1.3.0, and so on and so forth. You see it laid out there. And each of the routers are connected via a point-to-point link with only two IPs on the link. It's a /30 network. So now we can just dive right in. We'll look at this first router named Jake over here. We'll do show IP route, and you'll notice that when we investigate the routing table, we see a bunch of routes that have a code of C, and C is connected, and quite simply, these are the networks that are directly connected to this router. These are the networks that this router knows exists because it's directly connected to them. And obviously it knows the subnet mask because it has to be configured properly on the interface facing these networks. Now, obviously, for these 10.1 networks on this router, we're using loopback interfaces, but in an actual production network, you could use switch virtual interfaces or VLAN interfaces or actual router interfaces, depending on the platform you're using. And essentially, every network that is defined on an interface appears in the routing table as a connected network. The same holds true for the other two routers. If we do show IP route on Jane over here, we have the same connected networks, except Jane has one more because, as you'll recall, Jane is connected to both Jake and Roxy. If we go over to Roxy, we do show IP route. It knows about all of the connected networks here, and it only knows about the point-to-point link between Roxy and Jane. Now, since these are directly connected networks, I can ping any of the hosts on those networks. For example, one of my connected networks is 192.168.1.0/30, or more specifically, 192.168.1.4/30, since that's the interface on this guy. So if we do show IP interface brief, we see that this router has the IP of .6, so I should be able to ping directly 192.168.1.5. And because this is a directly connected network, I do not have to depend on any other routes, static or dynamic, to get to that .5. I can also examine the ARP table on this router, and you'll see that I've directly learned the .5 address from this device by virtue of the fact that it's on the same network, and I can just send out an ARP request saying, hey, give me your MAC address. Now, perhaps the more astute among you may have realized that Roxy doesn't know about any of the networks on the Jane router, and Jane doesn't know about any of the networks on the Jake router. None of these routers know about any of these other networks. And under normal circumstances, and later in this course as well, this is where a dynamic routing protocol would come in. However, since we're studying static routes in this particular video, we'll just set up static routes across all of these routers so that they all know how to get to all of the other networks. And I'll demonstrate this on one of the routers, and then I'll pause the video so that you don't have to see me enter the same commands on all three routers. Now, I've built these networks in such a way that I can also demonstrate summarization in this same lab as I'm building the static routes. For example, we're over here on Jake. We can go over to the Jake router, and we can tell the Jake router any networks that begin with 10.2.0.0/22 or 10.3.0.0/22 can be found beyond the Jane router. So let's go build those two static routes in the Jake router. So we go into config mode, and we're going to do IP route. You have to type out the word route. And there are a few other commands you can do in the IP route command, but in our case, we're just going to enter a destination prefix. So in this case, the destination prefix is 10.2.0.0. So 10.2.0.0. Now, I could enter each of these networks individually. In this case, I'd be entering 10.2.1.0 or 10.2.2.0, but we're going to demonstrate summarization. So now that we've entered the destination prefix, we have to enter the destination prefix mask. In this case, it's 255.255.252.0. And next, we have to tell it where to send this traffic. Now we can specify an interface, i.e. just Fast Ethernet 01, send all of this traffic out Fast Ethernet 01, regardless of what IP address happens to be there. And if you have a dynamic IP address, like a DHCP router connected to an internet provider, that's probably the best way to handle it. In this case, we don't, so I'm going to specify the forwarding router's address. So I'm going to say take all of this traffic and hand it to 192.168.1.2. So in this case, 192.168.1.2. So what we've done is we've said IP route, we're going to set up a static route to this network with this subnet mask to that router. If we hit enter, now we can show IP route over here. And now you notice that 10.0.0.0/8 is variably subnetted because we are now using VLSM on this router. We have a /22 as well as a bunch of /24 networks. Now I should be able to go ping 10.2.1.1, which is the loopback address on the Jane router, and it's shipped over to the Jane router, and the pings come back. Now some of you might think that the traffic shouldn't come back, and I'll explain why some of you might think that, and show you that it does indeed break under certain circumstances in the next video. So we're carrying on with our discussion of connected and static routes. We've just set up a static route from Jake over to Jane, and we have pinged an address that's over on Jane, and we've got a response back. Now, some of you that have dealt with routing before may have said, well, you didn't set up a static route back to your 10.1 networks over on Jane, so how did the traffic get back to you? It's because when you issue this ping command, the ping command by default uses the interface that is closest to the next route. So it sent out the ping requests with a source address of 192.168.1.1. Obviously, Jane knows how to get back to that because, again, directly connected route. So it pinged one of the loopback interfaces over here and just sent it right back to this 1.1. If we were to ping with a source address of 10.1.1.1, for example, the pings would fail. And let's do exactly that. So we'll do ping, and we'll use extended ping commands. And this is also a good troubleshooting method, so that you can ping from a specific subnet that's defined on the router. So we'll do IP, the target IP address will be 10.2.1.1. 5 pings is fine. Timeout in 2 seconds. Yes, we'll use extended commands. Source address or interface will be 10.1.1.1. Now that source address or interface has to be a valid address on the router. You can't do 10.1.1.7, for example, in this case, because that address doesn't exist, and it'll tell you you can't ping from that. And we'll leave all of the defaults for the rest of the options. And you'll notice that now our pings time out because Jane does not have a route to get back to the 10.1 networks over on Jake. So we'll build this reverse route over on Jane, and then I will pause the video while I build all the other reciprocal routes, if you will. So let's go over to Jane. Let's verify that the routing table doesn't have anything untoward in it, and there it is. It's still all directly connected routes. So now what we're going to do is we're going to do config t, and we're going to enter pretty much the same command over here on Jane that we did over on Jake. So we'll do IP route 10.1.1. Actually, we're going to do a summary. So we'll do 10.1.0.0 with a net mask of 255.255.252.0. And the next hop for all of those networks will be 192.168.1.1. 192.168.1.1. So now, if we go back out to the privileged exec and do a show IP route, we now have a static route that's a summary route for all of those networks. So now, if we go back over here to Jake, let's do that same ping again from 10.1.1.1 to 10.2.1.1. So IP, target IP address is 10.2.1.1. We'll use extended commands. Source address will be 10.1.1.1. Take all of the other defaults. And now our pings are successful because Jake has a route to get over to Jane. Jane has a reciprocal route for those networks back over on the Jake router. So now we'll pause the video and we will enter all of the routes on all of these routers. And now that all that's done, we can look at the routing tables and we can test our network here. So now we're over on Roxy. That happens to be the last router that I configured. So we'll do show IP route. And you'll notice that we have our connected routes as well as two static routes for the 10.2 and the 10.3 networks, both pointing at 192.168.1.5, because from Roxy's perspective, that's where both of those networks live, behind the Jane router. If we look at Jane, Jane's routing table actually is a little more complex than Jake's or Roxy's, because it has routes for the 10.3 network going out one interface and the 10.1 networks going out the other. So now we should be able to go over to Jake and do ping 10.3.1.1, which is one of the networks that's over here on the Roxy router. It's the loopback 1 interface, to be specific. If we do that from here, well, our pings failed. Why did our pings fail? Again, going back to what we discussed before, the pings are sent with the source interface address of this .1. Well, Roxy doesn't know how to get to the 192.168.1.0/30 network, or does not know how to get to this interface on Jake, so the packets get to Roxy, but Roxy doesn't know how to send the traffic back. And yes, I actually did that on purpose just to demonstrate this. When you build static routes, you have to remember to put every network in your static route table, including your point-to-point links, because you never know when you're going to get traffic that's sourced from those addresses, especially if you have any kind of NAT going on your network. And this is why, especially if you've watched the ICND1 course, you'll see that I say static routes should be killed with fire every time you encounter them, because this is an administrative burden to keep track of all of these routes. What if, for example, you took this 10.3.3.0 network and you moved it over here to be on Jane? Now you have to go update the route tables on Jake and the route tables on Roxy, and you can no longer summarize, so now you have to go build individual static routes for each of these networks on Jake and Roxy, as well as however many other routers you have in your enterprise. But enough of my evangelizing about static routes. Let's actually do the extended ping like we did before and show you that it actually works like it's supposed to. So we'll just do ping for IP 10.3.1.1, and we'll use extended commands. The source will be 10.1.1.1, and now the pings are successful because it's being sent from a source interface that Roxy knows how to get back to. So hopefully this has taken you a little further down the road to understanding connected and static routes. And that concludes our discussion of connected and static routes.